What if I told you that you can build a complete IoT project within ESP32, monitor temperature and humidity on two cloud platforms, and control an LED from your smartphone, all without owning a single piece of hardware? Well, in this video, I will show you how to simulate an ESP32 in Wokwi, connect a DHT sensor, send live data to Blynk IoT and Adafruit IO, and remotely control an LED from anywhere in the world. By the end of this video, you will have a fully functional IoT project running entirely in simulation. So make sure you watch until the end because this project is perfect for students, beginners and IoT enthusiasts. To begin, we need to open the Wokwi website. As you can see, Wokwi provides support for a wide range of development boards, including Arduino Uno, ESP32, STM32, and Raspberry Pi Pico. You can also explore many featured projects created by the community, which are great for learning and inspiration. Before creating our project, we need to create a free Wokwi account. Here you will see several sign-up options. I will choose Continue with Google because it is quickest and easiest method. Select your Google account and click Continue. That's it, our Wokwi account has been successfully created. And now we are ready to start building and simulating our ESP32 IoT project. After creating the account, I click on Arduino from the available platforms. Here, Wokwi display a collection of featured projects that have been created by other users. These projects are useful for learning different concepts and exploring what can be built using the simulator. Next, I select ESP32. Once again, Wokwi shows several featured ESP32 projects. Along with a number of starter templates. In the starter templates section, you can see different variants of the ESP32 family, including ESP32, ESP32C3, ESP32C6, and other development boards. Each variant is designed for specific applications and come with its own set of features. For this project, I will use the standard ESP32 development board. So I simply click on the ESP32. As soon as I click it, a new ESP32 project is created and the simulation workspace opens, where we can start building our IoT project. Before building our project, let's verify that the ESP32 simulation is working correctly. Wokwi automatically loads a simple Hello ESP32 example program. As you can see, the code is compiled successfully and the message Hello ESP32 appears in the serial monitor. Now I will stop the simulation so that we can start creating our own project. On the left side, you can see the sketch section. This is where we will write our ESP32 code. If your project requires external libraries, Wokwi provides a built-in library manager. To add a library, simply click on the Library Manager button and then click Add Library. A list of available libraries will appear. You can search for required libraries and add it directly to your project with just one click. Similarly, if you want to add hardware components such as sensors, displays, LEDs, buzzers or modules, click on the Add Part button. A large collection of components will appear, allowing you to quickly search and add the required devices to your simulation. This makes it very easy to build complex projects without need any physical hardware. Now that we know how to add library and component, let's start building our ESP32 IoT project. Now let's start building our circuit. First click on Add Part and search for the DHT22 sensor. Select it and place it in the simulation workspace. Next, connect the sensor pin to the ESP32. Connect the VCC pin to 3.3V, the ground pin to ground, and the signal pin to the GPIO pin 12. After adding the DHT sensor, let's add an LED. Again click on the Add part, search for LED and place it on the workspace. One useful feature of Wokwi is that you can easily customize the appearance of your circuit. For example, you can change the LED color by simply clicking on the LED and selecting your preferred color from the available options. Similarly, you can also change the color of the connecting wires. Just click on a wire and choose a different color to make the circuit more organized and easier to understand. Once all the connections are completed, it's time to upload the code. I have already written the complete code for this project. So instead of writing it from scratch, I will simply copy the code and paste it into the sketch editor. After pasting the code, we will install the Blynk and the DHT sensor library. If the library is not in the list, you can also upload the library. Before running the simulation, we need to configure the Wi-Fi setting in our code. Since Wokwi provides a virtual internet connection, make sure to enter Wokwi-GUEST as the Wi-Fi SSID and leave the password field blank. This allows the ESP32 simulator to connect to the internet and communicate with cloud platforms such as Blynk. Now let's set up our Blynk dashboard. Open the Blynk IoT website and click on Developer Zone. Next, click on New Template. Give your template suitable name. Select the ESP32 as the hardware and click Done. Once the template is created, open it and navigate to the data stream section. Here, create 3 data streams: temperature, humidity, and LED data stream. Assign virtual pins according to your code configuration. After creating the data streams, move to the Where Dashboard section. Now add the required widgets: a switch for the LED control and 2 gauges for temperature and humidity. For each widget, link it to the corresponding data stream so that the dashboard can display sensor values and control the LED. With the dashboard completed, we now need to create a device. Click on Devices and then select New Device. Choose from Template and select the template that we just created. Blynk will automatically generate a new device instance. Open the device information page and copy the credentials provided by Blynk, including the template ID, device name, and authentication token. Now return to the Wokwi code and paste these credentials into the appropriate locations. Now everything is configured and ready to test. Simply click on the Start Simulation button in Wokwi. The ESP32 will begin compiling the code and then start executing it. If you open the serial monitor, you will see the ESP32 connecting to the Wokwi-GUEST Wi-Fi network. After a few seconds, the Wi-Fi connection will be established successfully and the ESP32 will connect to the Blynk cloud server. Once the connection is complete, navigate to a Blynk dashboard. As you can see, the temperature and humidity value from the DHT sensor are being updated in real time on the gauge widgets. We can also test the LED control feature. Simply toggle the switch widget on the dashboard and the LED connected to the ESP32 will turn on. If you change sensor values in the Wokwi simulation, the updated reading will instantly appear on the Blynk dashboard. Toggle the switch again and the LED will turn off. This confirms that the two-way communication is working perfectly. The ESP32 is sending sensor data to the cloud while simultaneously receiving command from the Blynk dashboard. One of the best features of Blynk is that we can monitor and control our project not only from the web dashboard, but also directly from our smartphone. To do this, open the Blynk IoT mobile app and log in with the same account that you used to create the project. Once logged in, open the device that we will created earlier. Now tap on Edit Dashboard and start adding widgets. First, add a button widget. Next, add two gauge widgets. Connect the first gauge to temperature data stream and second gauge to humidity data stream. You can also customize the widget names, ranges and appearance to make the dashboard more attractive and easier to understand. After saving the dashboard, return the device screen and run the simulation again. As you can see, the temperature and humidity reading are now displayed on the gauges in real time. If we press the LED control button on the smartphone, the command is sent through the Blynk cloud to the ESP32 simulation and the LED changes its state instantly. Similarly, when the DHT sensor value change in the Wokwi simulation, the updated readings immediately appear on the mobile app. This means that we can monitor environmental condition and control devices from anywhere using our mobile phone, making this a complete IoT monitoring and automation system. Now we will upgrade this project by integrating Adafruit IO so that we can also monitor our data on another powerful IoT platform. First, go back to the Wokwi simulation and modify the circuit. We will add two more LEDs to the ESP32 setup. These LED will help us to demonstrate additional control and output from Adafruit IO. To add them, click on Add Part, search for LED, and place two LEDs in the workspace. Then connect them properly to different GPIO pin of the ESP32 as defined in the code. Since I have already written the complete updated code for this setup, I will simply copy and paste it into the Wokwi sketch editor instead of writing everything again. Now we need to add the required library for Adafruit IO. Open the library manager in Wokwi, search for Adafruit IO Arduino library and add it to the project. This will allow our ESP32 to communicate with Adafruit cloud platform. Now let's set up the Adafruit IO dashboard for our project. First open Adafruit IO and log in to your account. If you don't have an account yet, simply create one for free. After opening Adafruit IO, click on the dashboard section. Then click on new dashboard. Now give your dashboard name. You can name it something like LED control and DHT sensor monitoring. And finally click on the create button to create your dashboard. Now click on the new block button inside the dashboard and select the toggle block because we will use it to control our LED remotely. Since this is our first block, we now need to create feeds for the project. Create separate feeds for LED1, LED2, LED3, temperature and humidity. These feeds will allow the Shav ESP32C3 to send sensor data to Adafruit IO and receive commands for controlling the LEDs. Now select the LED1 feed, give the block a title such as LED1 and then click on the create block button. Repeat the exact same steps for LED2 and LED3 feeds so that we can control all three LEDs individually from the Adafruit IO dashboard. Now again click on the new block button, but this time select the gauge block because we want to display lab sensor readings. In the feed section, select the temperature feed and then click on the create block. In a similar way, create another gauge block for the humidity feed so we can monitor both temperature and humidity values in real time from the dashboard. Now let's arrange our dashboard layout for better visibility and control. Drag and position the LED toggle switches and sensor gauges in a clean format so everything looks organized and easy to use. Once you are happy with the layout, click on the Save Layout. Next, open the Adafruit IO website and log in your account. Go to the Dashboard section. Then click on the key icon in the top menu. Here you will find your account credentials. Copy the AIO username first and paste it in your code. After that, copy the active key and also paste it into the code in the correct section. These credentials are very important because they will allow the ESP32 to connect securely to Adafruit IO and send or receive data from the feeds. Once everything is updated in the code, we are ready to run the final simulation. Now you can see the final result of our project in action. From the web dashboard, we are successfully able to control all the LEDs in real time. Whenever we toggle the switches, the corresponding LED in the Wokwi simulation instantly turn on and off, showing that the cloud communication is working perfectly. At the same time, when I change the temperature and humidity value of the DHT sensor in the simulation, those updated readings are immediately reflected on the gauges in the dashboard. This confirms that our ESP32 is continuously sending live sensor data to the cloud and receiving control command without any delay. Now our system is fully functional, where we can both monitor environmental conditions and control devices remotely using the web dashboard. This completes our advanced IoT project using ESP32, Wokwi Simulation, Blynk IoT and Adafruit IO. We can also control and monitor this project directly from our mobile phone using Adafruit IO. Open the Adafruit IO on your smartphone and log in with the same account. Now go to the dashboard section where we have already created our widgets. Here you will see the switches for LED control and gauges for temperature and humidity. When we toggle the switch from the mobile dashboard, the command is sent instantly to the ESP32 running in Wokwi and corresponding LED turns on in real time. Similarly, when we change the DHT sensor values in the simulation, the updated temperature and humidity readings are immediately reflected on the gauges in the Adafruit IO. This shows that our system is fully connected and working smoothly across both web and mobile platforms. With this, we now have completed a dual cloud IoT system where we can monitor sensor data and control devices from anywhere in the world using both Blynk and Adafruit IO. This project is a great example of how powerful IoT system can be when cloud platforms and microcontrollers work together. If you enjoyed this video, make sure to like, share and subscribe to the channel for more ESP32, Arduino and IoT projects like this. If you have any questions or suggestions, drop them in comments. I will try my best to help you out. Thanks for watching and I will see you in next video.